expression up here I need to handle. So I want this to read 2x squared dx. So I'll divide both sides by -6. -6.
Wait, I have a question.
Yeah.
How is it du -12x squared?
So the derivative of this with respect to x, that goes away.
Oh, okay,
comes down.
okay. No, okay.
No, we did?
I thought the du was coming from the 2x squared. Okay, never mind.
No, sorry, no. It's a direct result from the first substitution,
Okay.
or the first, not really substitution yet, but the first making u a function of, I call it transformation. This first transformation. So du on -6 equals 2x squared dx. That's what we want. Okay. So now I can replace everything in the integrand. So it now reads the integral 2x squared dx becomes du on -6. I'm going to write this a little bit differently. So hopefully I'll make it clear. I'm just going to write it as -1/6 du. These two things don't have to associate so clearly, right? I can put the -1/6 out here. On the inside, I have 1 over the root of u du. So a second ago, I guess the way it might have been written would be this, -1/6 du. Agreed? The -1/6, and this is all multiplication again. The -1/6 just comes outside. I don't even have to place it here to begin with. I know where it's going to end up being, right? Any multiple of du, that constant multiple can always go to the outside, so there's no sense in making this look ridiculous. I can just put the -1/6 to the outside immediately. I'll leave it up here just one time. So now we have -1/6 integral 1 over the root of u is the same as saying u to the -1/2 du. Now you can do the power rule on that. So you got to raise the power up by 1, so it goes to a half. And you can divide by the new power. So you're dividing by half, which is multiple by 2. Okay? So you get -1/6, still on the outside. Antiderivative is 2u to the 1/2, and then plus c. So 2 times -6 is -1/3. Root u plus c. That's our answer. Oh, wait a second. That's not the answer.
What?
Sorry about that. And now replace u with what it is. It's 1 minus 4x cubed. So -1/3 root of 1 minus 4x cubed plus c.
Yeah.
There's a common theme in mathematics. Transform the problem to something easier, solve that problem, transform your answer back. That is a large portion of mathematical thinking. Hard problem, transform it. Something easier, solve that. Transform answer back into a real answer.
How'd you get 2?
-2? Because raise the power up by 1, so that goes up to 1/2. And you divide by that current 1/2 power. So divided by half is multiplied by 2.
I thought it was half plus 1.
What is it?
I thought it was 2 powers and plus 1.
Right. -1/2 plus 1 is positive 1/2. Divide by the new power, or take reciprocal of new power. So 2. And then just simplify. Yeah.
How is it 1 over radical u times -1/6?
So I'm replacing this
With u.
with u. The 2x squared, and then this portion here is that. Right?
Okay.
So are you just getting rid of the 2x squared dx?
The 2x squared dx is the same as -1/6 du. Once you declare that u is this function, then the change in u and the change in x can be related by this expression here, right?
You have to multiply by half.
Say
Are
again.
you joining
So
them
what's
back up together?
half of
Well, they're
2?
what, the du and the dx?
This is why it's just
You're combining u and du
You see?
and making it into 2.
It's like when it's like u
Oh,
to
it's like
the
what we did. This is the answer.
I'm simply taking the derivative of u. Once I say that u is a function of x, then there's some derivative, there's some change of u with respect to change in x. I found it. It's -12x squared, right? So that means du, the change in u, is related to the change in x by this particular formula now. But that formula is not sufficient for my work up here. I need to read 2x squared dx. So as long as I divide off by -6 over here, then this expression relates du and dx in a way that is useful to me. That is, I can now substitute a constant multiple of du in place of 2x squared dx. 2x squared dx changes exactly the same way negative 1/6 du changes.
Explain the last part.
What part?
The last part. Changes or
2x squared dx is equal to negative 1/6 du, right? So that means this changes, right? Du is a change in u. So if when u changes like this, x changes like this. So I'm free to now replace them at will anywhere I want. So I'm trying to change the entirety of this integrand from x's to u's. Because in the u state, it'll be much simpler to apply our known rules for integrals. Whereas over there, we got nothing right now. Right, in x I got, what rule am I gonna use? It's so complicated. My standard rules don't apply. But a small substitution, and now, look at it, it's just the reverse power rule. Raise power by 1, divide by a new power, gives over. Yeah.
How did that negative 1/2 u become positive?
Negative 1/2 u?
I mean, sorry, you.
Oh, do you negative 1/2?
Yeah. How did it become positive?
Because whenever you do the power rule for integrals, you raise the power up by 1 first.
Okay.
So negative 1/2 plus 1 goes to u to the 1/2.
Oh, okay, that's right.
Right?
Okay, that's right.
It's looking grim now. You guys are worrying me. I thought this was going to be an easy class. You got it, Rosales?
Yeah.
Yeah? Carter?
So you basically choose what u is and write the rest of the equation in terms of u.
Take the bottom piece.
Yeah. But you have to make sure that once you take that, what you should really do is glance over it, find the first basic composition you see, pretend in your mind that's u, differentiate it in your mind. So I got negative 12x squared, and then look at what you have left. Is it going to work out? Okay, 2x squared, that's not far off. It's only a negative 6 multiple off, so I can make this happen. But if it had worked out to be anything other than the exact same power, now we're worried. Maybe the wrong path we're taking. Maybe we need to take a different look at a different composition within the expression. In most of these problems, it will be the most basic one, right? It will be fairly straightforward.
You're taking both those two. You take 2x squared over root of 1 cube. You're combining them, and you're making them equal, right? And then you're taking that.
No, I'm simply.
You're taking the relationship between u, that function, compared to x, and how one changes how it affects the other.
Yeah.
And then you're taking that, you're taking derivative of that. I mean, you're taking that and make that, and then you find x and derivative of that. Does
Okay.
that make any sense?
I think so. I think you said it right. You just got to make sure that the rate of change of this expression is related to this change. And then that's what you're checking. And if not, then you need to do something else.
And that's how you get that one. You take those two pieces and you make into that one piece because they equal to each other. You see what I mean?
Huh?
Take that entire thing and then you make it into 1 over root of u to the negative 1/6 because your relationship between du and dx is equal at a certain point. You see what I mean?
That is, yeah.